Welcome, viewers. We want to solve this geometry question from paper 3, higher GCSE. Okay, this is paper 3, higher GCSE mathematics question, geometry. And this question has been given, and the target here is to prove that a triangle ACD is an isosceles triangle. What is triangle ACD? If you don't mind, I can shade this place. This is where they want us to prove. This particular triangle that I have shaded here with this color is what they want us to prove to them that it is an isosceles triangle. But then, how do we do this so that we get all the marks that are due for this question? What we are going to do, look at this line BD, line BD, okay? Line BD is a parallel line to line EG. Line BD is parallel to line EG. Therefore, if line BD is parallel to line EG, now it means that line CF is what we call transversal line. Transversal line. Okay? So it is a transversal line. What does that mean? Transversal line between two parallel lines create a lot of angles. Now, watch out and see that line or angle EFC is given to us as 125. The same EFC is alternate angle to DCF. So I can write that DCF is equal to 125 degrees. And what is my reason? My reason is that they are alternate angle, okay? They are alternate angle. So if EFC is 125, therefore DCF, that is, I'm referring to this place, should also be angle 125 degrees. My reason is put inside the bracket. Again, let us look at this place now, which is called ACD, line ACD. Line ACD is equal to 180 minus 125, and that is going to give us 55 degrees. How do I know about that? Because angles on a straight line. My reason is angles on straight line, okay, sum up to 180 degrees, okay? Angles on a straight line sum up to 180 degrees. Therefore, if I subtract 125 from 180, then this place now will be 55 degrees. Remember what the question has asked me to do, to show that triangle ACD is an isosceles triangle. But then, how do I know that this is an isosceles triangle? Once I get two angles that are equal here inside this triangle BCD, then triangle BCD is said to be an isosceles triangle. Now let's go on. I want you to see that ADE, line ADG, is a straight line. This is a straight line, okay? Therefore, any angle on it, or the sum of these two angles, that is angle ADC plus angle CDG, must be equal to 180. So I can write 110 plus angle ADC should now be equal to 180. Then I also need to put the reason down, that is angle on a straight line. So this is angles on straight line. Angles on straight line. So I'm putting it as shorter as possible. That means that to find the actual ADC, it means that the angle ADC now will be equal to 180 subtract 110. And that is now going to give us as angle 70, okay? So that is now equal to 70 degrees, meaning that the angle here is equal to 70 degrees. Beautiful. At this point, what is now remaining is angle CAD. That is this point. That is what is remaining. So let's go ahead and find it. To find that angle ACAD, to find angle CAD, angle CAD plus angle 55 degrees plus angle 70 degrees is equal to 180 degrees. What is going to be my reason here? Sum of angles in a triangle. You see, why I am putting the reasons down is because it is a part of the question. Give a reason for each stage of your workings, all right? So this is now sum of angles in a triangle. In a triangle, sum up to 180 degrees. With these reasons, you would be able to get all your marks without losing any mark. Now, this now implies that I am going to now find angle CAD. So angle CAD will now be equal to 180 minus the sum of angle 55 and angle 70. And 70 plus 55 will give me 125, meaning that that angle CAD will now be exactly 55 degrees. We are almost done with this question. Now, if we go back to the triangle, you will agree with me that this angle CAD is now 55 degrees. We are done. Watch and see that this place is 55 degrees. This angle also is 55 degrees. That is now what we will use to conclude. Therefore, we conclude that angle CACD, since angles ACD is equal to angle CAD and it is equal to 55 degrees. Therefore, ACD is an isosceles, okay, triangle. Thank you. And this is the solution for this higher GCSE mathematics question asked in the year 2023. Kindly subscribe to my YouTube channel for more videos. Thank you.